This is a problem similar to your lab assignment questions. This is from section 2.5. It says here, for what value of constant c is the function continuous? So it looks like this is a polynomial function, the first one, c times x squared plus 3x, and then we have another polynomial function. So those things are going to be continuous. The only thing is that this is a piecewise function and it breaks at 4 when x is equal to 4. So what we want to do is we want to find a value for c so that these two things are equal to each other as the limit approaches 4 from the left side and from the right. So as it approaches 4 from the left side, we're going to consider this function where for x is less than 4, we're going to need to use c times x squared plus 3x. And coming from the right side, when x is bigger than 4, we'll be using x cubed minus c times x. Alright, so step 1. Note that f is continuous from minus infinity to 4 and 4 to positive infinity. For the function to be continuous everywhere, we need to ensure that as x approaches 4 from the left and right limits, then it's going to be the same. So first we take a look at the left limit. Again, we use this first function because those are the values, that's the function that we use for x values that are less than 4, and that's what happens when we approach from the left side. And so as x approaches 4, since this is a nice polynomial continuous function, all we have to do is put 4 in. So we put 4 in for x, and we get x squared, that's 4 squared, so that's 16 times c, and then we add 3 times 4, which is 12. And then likewise, as x approaches 4 from the positive side, we use the other function, and again we put the value of 4 in. So 4 times 4 times 4 is 64 minus 4 times c, c times 4 is 4c. Alright, so let's check that. Looks good so far. And now these are the y values for the limits, and so what we want to do is we want to make sure that they're equal to each other. So we set them equal to each other, comparing the two limits and solving for c. This is going to be in steps, so let's take it in steps. We got 16c minus 4c. We bring that over to the left hand side, you get 20c. And then we have 64 minus 12, and I think that's going to be 52. And then when we solve 52, enter fraction, integer, exact, do not approximate. So 52 divided by 20, I think 4 goes into 52 13 times, and 4 goes into 25 times. So 13 fifths. Okay, so we've completed this particular problem. Let's take a look at a graph of this, because I think the graph is kind of interesting to look at. Here is kind of like an animation type thing, where we took a look at the graphs of each of these things. So c times x squared plus 3x when x is less than 4, and then we have x cubed minus c times x when x is bigger than 4. Technically it should be bigger than equal to. Let's try that again, bigger than or equal to. But it's not going to matter because we're going to take a look at this graphically. And then I had to fix the range, the domain and the range, so that the graphs will fit. So this y value goes all the way up to 80-ish. And so what we want to do is we want to adjust the value of c, and then if we slowly adjust it using this sort of animation slider kind of thing, then we would kind of see it approaching each other. And then we get to this point where, oh, it's about 2.58, and if we go past that, and then they pass each other again. So it looks like it's about 2.58. We get the exact value, we can put 13 divided by 5, which was the value that we found, and we see that they are actually connected. So we follow this from the left side, we follow this from the right side. Oops, I guess that was the right side and the left side, and then we get to that point. If we do want to know that point, it's about 53.6 for the y value when x is equal to 4. All right, so that's this problem, and I hope that helps.